pause the video and attempt this question before continuing. Okay, so 8-digit numbers need to be formed using these digits, and the digits are 1, 1, triple 2, 3, and 2 times 4. Okay, and then we have a restriction which goes like this: odd digits do not occupy the odd places. Okay, how many such numbers exist in which the odd digits do not occupy the odd places? Okay, suppose this restriction were not there and we just needed to arrange this 8 digits to form 8-digit numbers. So in how many ways could we do that? So there is a property wherein you need to arrange n items or n objects at n places where p objects are of one kind, q objects are of another kind, and r objects are of yet another kind. Then the number of ways of doing so is given by n factorial upon p factorial multiplied q factorial multiplied r factorial. Right? So this is the number of ways of arranging n objects at n places where p are alike of one kind, q are alike of another kind, and r are alike of another kind. Right? Extending this property to this particular case, if we are to arrange these 8 digits, the total number of ways would come out to be 8 factorial upon 2 factorial because there are two ones, multiplied 3 factorial because there are three twos, multiplied 1 factorial for 3, and 2 factorial for 2 fours, right? So this is what we would get as this the result for this. However, whenever you have a restriction, what you do is you first apply these. The way to solve permutation question is that you first try to satisfy the condition or use the restriction and then solve the question. So what you will do is first assign slots, 8 slots corresponding to the 8 digits, and number them 1, 2, 3, 4, 5 so that we can keep track of even and odd places. Now the question says that odd digits do not occupy the odd places. So which ones are the odd places? So this is the odd place, this is the odd place, this one and this one. So these red ones are the odd place. So we do not want the odd digits to go in these places. So basically the odd digits can go in either here or here or here or here, right? So there are 4 choices for the odd digits, and which all odd digits do we have? So let's mark them also. So this is my odd digit, this is odd digit, and this is odd digit. That's it. So there are three out of 8 digits which are odd digits, right? Now these 3 need to go in 3 places out of these 4 even places, right? Because odd is not a choice. They have to go to, and there are 3 digits, so they can only occupy 3 slots. But we have 4 even slots. So what we need to first do is first need to choose 3 slots out of those 4 slots. So that can be done in 4C3 ways. So what we are doing is out of the 4 slots, 4 even slots, we are choosing 3 slots, right? Once we have chosen 3 slots, now we're going to arrange those 3 odd numbers at those 3 places. In how many ways can that be done? It's the same as this case, right? Arranging 3 objects where 1 is twice and 3 is once, right? So that's it. Now once you have arranged the odd numbers at those 3 places, what you need to now do is arrange the remaining 5 numbers at the remaining 5 places. In how many ways can you do that? So basically this is again an AND operation, right? So it's basically the fundamental principle of multiplication. So you multiply here, and then 5 objects to be arranged where 2 comes 3 times. So divided by 3 factorial multiplied 4 comes 2 times. So you have a 2 factorial here. So basically, if you solve this, so 4C3 is 4, 3 factorial upon 2 factorial is 3, 5 factorial by 3 factorial is 4 into 5, 20, divided by 2 is 10. Right? So the value that we get is 120. So in all, there are 120 such 8-digit numbers which exist under such restrictions. So the correct answer to this question is choice B. Thank you.